Welcome to the Cosmic Pie Podcast, Season 2, Episode 32. This is our last one for the year, Robert.
Last one for the year.
Had to think for a second. Just wait a minute now.
Last one for Season 2. So.
Last one for Season 2. So
Yeah.
rewind the clock back to episode number 1 coming up in a few weeks.
All right.
But Season 3. I'll probably
Season
still say 2 for... It's like when you're writing the date down and when the year changes, right?
Right.
You're using 2024 for the first few weeks for you.
Yep. Unless you stop and think about it. And then you're like, oh, wait, no. Remember when you used to have to do checks and
Right,
date
yeah.
them? And,
Yeah.
Yeah,
So-
we're showing our age now, folks.
A check. What's that? So we do have a live chat feature that is running. So if you want to send any comments or have any questions about anything that we're talking about or anything we're not talking about,
Yep.
please feel free to use that feature. And we
Yep.
also have our...
Our disclaimer that the opinions expressed herein are those of myself and Wayne. They are not the opinions of the university, the Department of Physics and Astrophysics, UND, any of that. It's just us. Blame us.
The other thing we should say up front is that our next episode,
Our next episode,
which will be
season
episode
3
1,
of 1.
will be in 2025. So that will
Yep.
be 2 weeks from today, January the 7th.
7th? Yep, that's right.
January 7th.
Yeah.
So we're still going to be on a Tuesday, and we're still going to have it at 5 p.m. Central.
Okay.
And that assumes that I can make it.
Right.
You know what else happening on January 7th?
I know what's happening on January 7th. Do you want to announce what's happening?
Yeah, I've been called for jury duty. So I don't know what's going to happen. We'll see if I get dismissed early enough that I can make it back here. Or maybe sometimes you got to call them up after 5:30 the night before.
Right.
And they'll let you know whether or not to show up the next morning at 8 a.m. sharp. But I'm doing my civic duty.
There we go.
I am ready and anxious to go.
Being a good citizen.
And I will analyze everything in detail like a good scientist.
Right.
So therefore, they don't want me, right?
Therefore, they don't want you.
That's what they say, but I don't know.
Yeah.
I don't have
Anyway.
site.
But
I'm just doing it ahead of time. You see the preamble here, so
Right.
then they will turn me down right, if they catch this podcast.
we'll be letting you know how that January 7th podcast go. Who knows? Maybe it'll just be me here. Maybe we'll get a guest just in case.
Or I might be able to make it back from the courthouse
might
in
be able to
time
make
for
it back.
5 p.m. local.
So,
So you might see me scramble in at 5 after 5 or
which
something.
does make me remind me that we might have to play a little bit with the time because I'm taking a class that ends right about the time we start. So I will be hoofing it over here.
Yeah, we'll see how that all
We'll see how it
pans
all
out.
pans out.
Yeah,
we
we
may
might
be 5 or 10 minutes late. So.
We might have to change the time a little bit.
Yeah, just tweak though.
Okay.
Just a tweak.
A new semester, people have new schedules, so you never
That's
know.
it.
what
you never know.
happens.
You never know what you're going to get.
We're just happy we find time to do this.
Absolutely.
To talk things that, a lot of times we don't know what we're talking about. Well, we're just talking, right? And before we get too in depth, today's talking,
Yeah.
I should like to say, and I will say, that today is also a special day, December the 17th. It is my father's birthday, and he turned 85 today.
Woo!
So happy birthday, Dad.
Happy birthday.
And it's not too often that a podcast falls right on the day of somebody you know's birthday.
Right.
You see that day of the week in the date itself.
Yep.
So that worked out well. So our first one we're going to look at today in terms of the news related to space exploration is a little bit of an update on Ingenuity. Now, do you remember Ingenuity, Robert?
Ingenuity was a little double-propped helicopter that flew around on Mars for a little while until it caught a piece of the side of a hill and with one of the rotors and crashed, fortunately landing on its feet, but it crashed.
In fact, you have a really good memory, Robert. Anyone
Yep.
ever tell you that?
I have a very bad
I don't
memory.
remember. I never told you that.
I don't remember anybody ever telling me that. I can say when I'm looking at a picture, it will jog my memory, and I can remember a lot of stuff about it. So
Well, NASA released a couple days ago essentially the crash report. Anytime we have a major crash, we send out the representative of what, the TS. What is it they
not
call
the
it?
TSA,
No, the
FAA.
NS,
FAA.
or there's a board, right? The National something safety board or something.
Yeah, something like that.
Transportation safety board. NTSB.
NTSB.
That's
yeah.
it. They send out. They do up a report usually a year later or something like that.
Mm-hmm.
And in this case, it was about what happened to Ingenuity, why the helicopter crashed. Now they don't know and of course they're doing this remotely, and they speculate, oh, there's no black boxes because we can't get to the helicopter
Right.
and determine what happened exactly. Not now, in the future, hopefully it'll work. But the thing is that they said a contributing factor to the cause of the accident is that the navigation system on board the helicopter uses different things, including cameras, to see
Okay.
where it is versus the train, the relative, separation. It turns out when you're flying, it's like this image would show you, if you're flying over an area like that, where are the land features and how high above them are you?
Well, clearly it wasn't high enough.
Right? Because if you have like sand dunes and things and the contrast is so low on the
Right.
surface, there's nothing that sticks out. As some people like to say, there's no telephone poles anywhere that you can get a size relationship with.
Right. It's like if you're flying over on a cloudy day, flying over a clear lake. Where's the lake and where's the cloud?
Yeah, it can be disorienting.
Right.
And so that's essentially what happened is the navigation system become disoriented, would be a way to put it. I didn't quite know exactly where it was relative to the surface. And that's what caused it to run into
A sand dune.
a sand dune and rip off one of the rotors, break it off.
Yep.
And that was the end. But the interesting thing about it is that Ingenuity is fine. And they said because there's no sensors on board that actually check the status or the state of the rotors, that it would report, and it has reported back, that everything is green. Like there's nothing wrong with it. The power source is still going and so on. In fact, they can use the helicopter Ingenuity to take daily images and weather measurements.
That's still kind of cool.
And it's still doing it.
Cool.
So it's really a weather post in some sense, right?
Isn't it too far away now from the rover?
It is.
was part of?
You have to be, I think, line of sight pretty well, right, to communicate with the rover, and then that would get radioed back, the data.
Mm-hmm.
So it can't radio the data back to Earth,
But it's keeping record of it.
but it's keeping a record. In fact, the little bit of data that it gathers in terms of the storage capability on board the helicopter is such, as you see there written, that they can store up to about 20 years of weather data and single images every day.
That's still phenomenal.
Yeah, so this idea that somebody will go to it someday,
Yep.
land on Mars. Maybe a rover will do it, like a robotic mission, or maybe a human mission.
Right.
And they'll just dump the data out, take the card out of it or whatever it has into it for a storage device, and be able to have all of that data for literally 2 decades worth of observations of the weather and conditions and images.
That's important information. That's something you want.
Yeah, so that's quite interesting when you think about it.
Absolutely.
And the other problem with this, of course, is that this mission, Perseverance, it was designed to gather samples in different interesting spots on Mars and deposit those samples in like a test tube type device. Remember that?
Yep.
The ideal being that we will go back to Mars relatively soon.
With a sample return mission.
Yeah, with a sample return and a robotic mission. It wasn't with humans, but that will happen hopefully in the future. But that sample return mission now is in a lot of financial difficulty.
Well, I mean, it's an expensive mission. I mean,
And unfortunately, as time goes on, when you're engineering it, it got more expensive and more expensive. So it's billions and billions of dollars. In fact, there's been layoffs from Jet Propulsion Laboratory in the last several months.
wow.
And a lot of people are saying this is the result of it. It's the overspending on these missions like the sample return mission.
Right.
And so NASA, I know issued a call of proposals because I received an email from them because you can sign up to their email list.
Mm-hmm.
And it is looking for ideas to make a sample return mission to Mars, but make it much cheaper than what they had presently thought about.
Well, I got to admit, I think part of the problem is, and I think this is rife throughout the sciences, we have a tendency to try to get these bids, get these grants, to underestimate what they're going to cost. We kind of live in that rose-tinted glasses zone of, this is what we can bring it in for. Instead of that, it's probably going to be this much.
And there's also the engineers take a lot of heat at this point.
Right.
Because the common statement would be that if you give anything to the engineers, they'll just keep designing new things and adding to it and adding to it and
Yeah.
adding to it. But along with that, of course, is the cost.
Hmm. There comes a point where you got to say, hey, it's good enough. Let's get it going.
Well, if the mass of the vehicle becomes too great, then they got to go to a larger launch vehicle, and that means an increase in cost.
Or potentially 2 launch vehicles.
Or split it in
3,
2,
or-
right? Yeah, so that becomes a real issue at some point. So right now, the status of the sample return mission is question mark. The push in all of this is
Is that what you wanted?
no, but
okay.
you can leave it there. It's fine.
Okay.
The push in all of this, of course, is when other countries plan their own sample return missions to Mars.
Right.
Can you think of a country that might be in the position to do this in, let's say, the next 10, 15 years?
It's probably not the Soviet Union.
There is no Soviet Union, Robert,
right.
remember.
Right.
Remember,
That
it's-
memory thing.
Remember, Robert, it's Russia, Russia, Russia.
Right. I would probably guess China is the one that's likely going to be the danger of doing it first.
Yeah, it's China. I mean, they make no bones about it that they have a very aggressive space program, and their long-term goal is to do things like that, go to Mars, first, of course, unmanned it, and get their material. I mean, they've sent stuff
Yeah.
there already, right? But I mean, to pick up samples and actually return them to Earth.
Right.
That's what we're talking about here. And eventually, of course, doing that with human beings landing on Mars and coming back and returning that stuff to China. And so that will tend to push, especially for the United States, into doing something.
Right.
That'll be the emphasis, at least, because it's all politics.
It's all
Politics is everywhere.
Yeah.
And politics is in NASA's budget as well.
It's politics and bragging rights.
So we'll see how all that plays out in the future.
well-
I don't have an idea.
I say politics and bragging rights. The money to fund it is politics and bragging rights. The science done is, we've seen the results of it. We're still living on what was discovered and brought back, doing the moon missions.
Yeah,
So,
well, the moon mission, the science was an aside. It wasn't even
I know
close
it
to
wasn't.
being the main
It
emphasis.
wasn't, but it's still look at what it did.
Yeah,
for us.
it was all politics and
It was-
bragging
yeah.
rights. Just a very small part of it was the science.
Right.
If you said we're going there for the science,
Oh,
they
and
would
it
say,
would have never
oh,
happened.
well, then if you pay for it, you can go there, right? Just
Right.
don't spend my money on that. So that's the thing. So we're always thinking ahead, and that is the case with the Ingenuity Mars helicopter, that you're going to come up with a new version. In fact, the original one, as you mentioned, was only supposed to survive for a few flights,
If you like.
and they did tens of flights, so it worked out a lot better than what they initially had thought.
Right.
And
It's like the twin rovers we mentioned earlier. They were only guaranteed for 90 days, and they went on for 11, 12 years.
yeah, so remember that you remind me of the quote that I gave during my talk last Monday on the Pioneer 10 and
Oh.
11 mission.
Oh, okay.
Do you remember that quote?
I don't.
So I'm starting to laugh
We're back
already.
on my memory.
Yeah, I thought you got this great memory, Robert. What
Yeah.
happened? Anyway, so if I think about it now, I can actually bring up the actual quote. So we're talking about the Pioneer 10 and 11. So these are spacecrafts that were launched in the 1970s on their way to explore Jupiter and Saturn in the case
Saturn,
of Pioneer 11, who went to Jupiter and Saturn. And they were both built by TRW engineers, right? So it's a company in California. I don't know if they're still around today or not. A lot of these aerospace companies merge and go
Yep.
away and become new companies or whatever.
Or get split up between.
Or get split up, yeah.
Yeah.
So I'm not quite sure, but here's a quote. And so remember, these spacecraft are being launched to Jupiter and Saturn in such a way that they are escaping the solar system, never to return. So
Right.
they gain enough speed to leave the solar system to essentially go in orbit around the Milky Way, the center of our galaxy. So here's one of the quotes from the engineer. This spacecraft is guaranteed for 2 years of interplanetary flight. If any component fails within that warranty period, just return the spacecraft to our shop and we will repair it free of charge.
Right.
So, and that would never happen because how are you going to bring back that spacecraft?
I was about to say 2 years. They're at Jupiter by then, or just about.
There's a great warranty for you. You
Yeah.
never can use it, right? You're forever safe. Anyway, so the next generation of one of these Mars helicopters is the one you see here that's been proposed. There's actually a meeting going on. I think it's just finished up or it's continuing this week. And it was presented at this meeting, the one proposal, as you see here, called the Mars Chopper. And instead of having just a one rotor with the two blades
Yeah.
spin around, it would have 6 rotors, as you see in this
Okay.
this diagram, and each of them would have 6 blades. So 6 blades per rotor in that sense, right?
Yeah. You don't have to spin them as fast when you've got that many.
Well, the other thing is you can carry
Airfoils.
more stuff. That's
So
the
you
goal.
can carry more stuff. Yeah.
In fact, it's going to carry about 11, as designed here, if this design actually makes it all the way through all of the checks, right, and the alterations and revisions that happen. If it makes it all the way, then this particular design would carry up to 11 pounds of scientific instruments.
That's quite a payload.
And it'll be able to fly up to nearly 2 miles a day coverage. And it would go on and on and on and on. You can see the solar panels and stuff there. So this you could go for a year on Mars or whatever, right? But you can imagine the places that you could go and explore.
Right.
The Valles Marineris, the
I was
Grand
about to say
Canyon
you could go down
on
in the
Mars.
Valles and you 2 miles. No, you couldn't reach the top of Olympus Mons. Plus the thinness of the atmosphere.
Well, you could do it in several days.
Yeah.
But you're carrying a lot of mass, 11
Yeah.
pounds of scientific instruments. So you do a lot more detailed measurements of the land, the surface features, all these kind of things. But Valles Marineris, we always say that's the Grand Canyon of Mars. It is actually many times larger than the Earth's Grand Canyon. And there you'd see different layers. So going back in time, imagine the rover hovering as it's descending along the wall of Valles Marineris, taking very fine, detailed measurements.
Yes.
Or even taking samples, hovering one spot, like a
If it had an
hummingbird,
arm.
like a hummingbird with a little thing that comes out, sampling, grab a sample, a core sample of that material, and then doing it at different depths along the wall. So you're looking back at different eons
I'm on board.
in the history of Mars.
Heck
It
yeah.
would be fantastic. Looking for signs of maybe a watery Mars
Right.
in the past, or anything like, or maybe who knows,
Because
fossilized nanobacteria.
Because that's one of the things that the Grand Canyon allows us to do, is because much of the top few layers are sedimentary, which comes from water. So, water or air, because you got sandstones that can be deposited by airflow. But down towards the bottom, you get down into base rock, you get down into granites and schists and things like that. And I'm geeking out on my geology training.
Well, just think of what caused Valles Marineris to form in the first place.
Was it cut by water, or was it
Think
split
of what the
apart?
Colorado River and the Grand Canyon is. Are we having a similar type of mechanism here at play,
Right.
or not?
Is there maybe water still down there?
Yeah, maybe you just got to. I mean, it's a lot easier to look in depth through the ground, going along the wall of a canyon, than to drill.
Right.
NASA tried that recently with the InSight lander. In fact, we'll talk about that a little bit later today in the podcast.
Okay.
Where they try to put a core. Remember, they call it the mole.
Yes.
Try to get it to go down, like I think it was up to 10 feet below the surface, and it never worked. And the reason for it is the constituency of the soil was such there wasn't enough friction for the mole to bite onto to allow it to slide downwards. It kept spinning. It's like us trying to drive on ice around here this time of the year,
Right.
here in Grand Forks, right? So that's an issue. So if you don't have the soil properties figured out correctly, that impacts, of course, those type of measurements. So going along the wall of the Valles Marineris is the best way to do that, for sure.
We have a question. Nanobacteria, would that be mycoplasma? I actually had to look up what mycoplasma was. And non-biologist here, I would have to say yes, they would be related or similar things, because mycoplasma are bacteria that can infect different parts of your body. And
Yes.
that would be one of the problems with bringing back any samples from Mars, is they would need to be strictly contained, because if there ever was life on Mars, well, we're waking up nematodes from the permafrost that are thousands, tens of thousands of years old. Who knows what we could wake up if it ever was there on Mars.
Well, the thought process in the past was always be that you would bring any type of samples, let's say from Mars. You wouldn't bring them directly back to the Earth. You'd go on board the space station, the International Space Station, or something that replaces it in the future, if there is, and keep it there for a while. And that way you're not contaminating the whole Earth, right?
Right.
And hopefully it's better contained than the COVID virus, when you do it that way. But the International Space Station is going to go away in a few years, somewhere
Right.
in the early 2030s, probably going to dump in the
And-
Pacific Ocean.
And with no plans to replace it
No,
with
not at
anything.
this moment. So who knows what's going to happen. The other thing is the nanobacteria, nanofossils of bacteria, that come to play in the 1990s.
Mm-hmm.
So when
I
it was
remember that.
You remember that?
Yep.
So, and even Bill Clinton at the time when he was president made a statement in the press about this. And the idea was that if we look carefully at rocks, so if we go to Antarctica, an ice sheet of Antarctica, there shouldn't be any rocks laying on top of the ice sheet. They should be all underneath.
They should all be underneath.
And you go around, and what you discover is you see rocks laying on the surface. It's like, where do those rocks come from? They came from the sky. They're meteorites.
They're meteorites.
Versus meteorons, as the joke goes, right?
That's the joke. Yeah.
So they collect the meteorites. Scientists scan, the ice sheet of Antarctica, and they've been doing that for many, many decades. And they take them back to laboratories and study them. And of course, if they're laying there for any period of time, we know they can get contaminated by stuff in the Earth environment. So you try to get them as soon as they fall, but you don't see them falling all the time. So that's problematic. Anyways, there was one particular meteorite that was discovered. And when they looked at the composition of the gas that was trapped inside pockets in the interior of the rock, that gas has the essentially identical composition of what was measured on the Viking landers on Mars.
Right.
So the idea is that rock came from Mars.
And this gets back into the isotope and the molecular ratios of gases and so forth are indicative of the source.
Well, look at the moon, full of craters. And those are impact craters, not volcanoes.
Right.
You look at Mercury, same kind of deal. So we know that there's lots of things in the past and things that are even happening today occasionally where rocks will hit a planet. And a rock hit Mars many millions of years ago, as far as we can tell today, this one particular example. And the impactor hit Mars with such a force that some of the debris that was thrown outwards reached escape velocity, actually went into orbit around the sun, some of the small pieces. And eventually the Earth went through that same region of space, and the rock then came through the atmosphere and landed on the Antarctica ice sheet, and then later on was found by humans.
Right.
And that's how you're able to get a rock then that came from Mars. And essentially it's a freebie, right? We didn't have to go to Mars and spend the money for a robot mission to bring back a sample of Mars. A sample of Mars came to us naturally, if you like. The problem is, though, it's laying on the surface and gets contaminated. So in this particular sample, when they looked at it, they saw evidence, some scientists suggested, of nanofossils produced by nanobacteria.
Right.
Others at the time said, wait a minute, maybe they're chemical type of things, not biology. So there was a bit of a controversy. In fact, there was a press conference at I think the Johnson Space Center by NASA saying that we possibly have the first evidence of life that originated somewhere else besides the Earth.
And it's because these little deposits of minerals are shaped like what we expect bacteria to be shaped like. However,
Well, the thing...
when they were analyzed, they are mineral.
Well, yeah, and there's still some...
There's still some that cling to the fact that, oh no, it doesn't show the signs of that we expect to see from fossilized bacteria.
Right. And the other thing is, even if it was nanofossils, how do you, or some biology related thing, how do you know it didn't come from Earth?
Right.
In fact, didn't we remember the sample of the, was it Ragu, the comet? No, asteroid Ragu, remember recently?
Right.
That's contaminated by earthly, environment. Things in our environment are contaminating the sample. So even under clean room conditions, the samples are being contaminated.
Right. As careful as you are, sooner or later, it comes in contact with something.
Yeah, it's like COVID again, right?
Right.
How careful you are, it gets spread eventually, right?
This is why we've outlawed, biological warfare. It gets out, it gets away, and it affects you as much as it does anybody else.
So to prevent that idea where something gets contaminated by Earth, you want to go there, grab those samples, and if you can, the best thing is analyze them at Mars.
Right.
Don't bring them back to the Earth.
Yep. But if you need to bring them back to Earth, bring them to a space station.
Now, our electronics and robots are so sophisticated. AI, I'll use all these buzzwords that people are used to death. Everything is AI, AI, AI. well, send AI to Mars, and they can analyze these samples to tell us what they're made up of and not risk anything coming back to Earth at all.
Right. I mean, it shouldn't be a problem really to
what?
set up a lab.
Well, we got
Mars.
a lab in Antarctica.
Yeah.
Right?
And I'm talking about a big lab, not just a rover lab.
Yeah. So it's just, all it is money. When you think about it, it's money, 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 money.
Or more to the point, it's resources.
If we didn't have like a $36 trillion deficit, maybe we'd have an extra cash that we could do that kind of stuff, right? That's the problem, right? It's where do you spend the money on?
Right.
Or where do you borrow it from to do what with it, right?
That's it.
Anyway, so we'll see how that plays out. So the next update is related to the Parker Solar Probe.
Yay, I like Parker.
You remember this?
I remember the Parker Solar Probe because, I just think it's a cool thing where you put an ablative shield on it so that you can fly it through the sun's corona.
Yeah. In fact, the hype around this, you could see it was launched in 2018. The total mission objective in one statement, it was designed to touch the sun.
Yep.
And that's literally what it was designed to do. As Robert said, it would fly through the corona, the outer atmosphere of the sun that no other spacecraft had done before, and take measurements.
Mm-hmm.
And it's extremely hot, millions, but
it's got an ablative shield that's slowly wearing away every time it makes a close approach.
yeah, and the probes are like behind the shield, so it's like you stick out a probe a little bit. It's like putting down the car window.
Yeah.
And sticking out a little device barely to measure the wind speed.
Now, I will point as we have several times on this show, that it's very low density, and that temperature to an astronomer just means average speed of the particles that are there. So this ablative shield isn't ablating away very rapidly. It's a slow process because it's just not encountering many particles. But the particles it encounters are moving very fast, and for their size, do a lot of damage.
In fact, the Parker Solar Probe will fly the closest. It's been up there for a few years now. As I mentioned, launched in 2018. It's made several passes of the sun, getting closer and closer each pass. So it'll make a pass on Christmas Eve. So
nice.
Not very far, a week from now, essentially. And it'll come within, this is the closest it's ever done, so no spacecraft has come this close to our sun, of 6.1 million kilometers. That is really close.
That's really close to the star.
Yeah.
And I was just going to point out that it's taken this long. It's got to slow down. It takes a lot to bleed off the amount of energy you have just from the orbital motion of Earth. So
yeah, it's very difficult to actually send spacecraft to like Mercury because of that.
It falls faster and faster.
Yeah, usually nowadays when we send space probes to inner planets, they're always doing lots of swing by of Venus and Mercury. In fact, Europeans, the Babel-Sax mission is on its way to Mercury, but it's been on its way for many years now.
Because it's got to bleed off all that momentum.
And unfortunately, when I remember when that mission was first launched, and it would show you the trajectory. It would go loop around this, back to Earth, go back to Venus, back to Mercury, past Mercury, back to Venus, back to Earth, and all this kind of, oh my God, why can't we just go there? And then you realize that it would take a very powerful rocket, and therefore a lot of money, to make this direct approach to Mercury.
Either that or you'd be doing a flyby.
Yeah, way too fast. And we've done those in the past with the Mariner missions and Messenger spacecraft that was in orbit around Mercury. So we had good measurements of that. But this spacecraft, right, it takes a while to get there. It should have been there now, but they had a thruster problem.
Oh, I had heard about that.
Remember that? So I think we talked about it a long time ago, but they couldn't slow it down in time. So it's actually got to take another loop. So they add another year to it. So in a year from now, it'll be back to Mercury.
Okay.
And then it should be able to go into
then it
orbit.
Should be able to orbit and slowly get closer and closer.
So they tacked on another year, unfortunately, because of mechanical problems to the overall mission. Even though it was long to begin with, that's what I'm getting at. Wait, even longer.
So Parker is going to make the closest approach yet at 6.1 million kilometers. And it's going to be going 90,000 kilometers per hour.
Yeah.
That is fast.
The fast. And right now, Parker Solar Probe is the fast. If you Google it, it is the fastest human-made object that ever existed. And it's going to break its own speed record next week. So
eventually it's going to burn up. That's the plan anyway.
Well, yeah. So it's really interesting anyways. So we're really getting in depth, in situ, as we say in science, measurements
Of the sun.
of the sun and its magnetic field and the interaction with charged particles. All of that's important. Why? Because one of the things, and we'll talk about this later on today, is that the sun is not a static,
Body.
bland sort of sphere that you think it is when you look up at it and you glance at it, like you see the photosphere, you don't really see anything, no features, doesn't really seem to change day after day. But that's not true. It's a very dynamic type of object. In fact, there are different, eruptions that occur on the surface, solar flares and so on, that help energize the environment around the Earth, creating northern and southern lights, so on and so forth. So it's important with our technology. We have so much reliance on things that are in orbit around the Earth that are basically, open to any type of damage that may be created when the sun is really active.
And if I may segue a little bit, solar flares, by the way, folks, in our image that we currently have up, all those little bright spots, those really bright spots, those are flares. That's all a flare is. Those loops and everything else are called prominences.
Yep.
So now flares are often associated with prominences, but they are not the same thing.
Yeah, and flares, you can get a lot of particles get ejected from the surface of the sun. They reach escape velocity.
Yep.
And if the Earth happens to be in the right or wrong location, as we'd say,
Depends on how strong it is.
yeah, those particles will hit our upper atmosphere. And thankfully, we have a magnetic field that kind of takes the punishment. Those particles get trapped because they're charged, get trapped along the magnetic field lines, and they usually make their ways along to both of the poles, the magnetic North Pole and the magnetic South Pole. And when those particles crash into the upper atmosphere, they energize the atoms and molecules in our atmosphere, and that causes them to then release that energy by emitting light. And that's the northern and southern lights.
Yep. In fact, we ought to get Vincent back again someday.
Yeah, he's got all the pretty pictures that he
See all
takes
the pretty
of
pictures.
aurora activity.
He works with aurorists, folks.
Yeah.
So, all right.
So we talked about Mars when we were looking at the helicopter. Kind of should have reversed slides here, but didn't quite know which way the conversation goes, of course, a lot. But this gets back to the InSight mission that we talked about. Was trying to send a probe, the mole, down through the surface and wasn't able to do that because it didn't get enough traction to allow it to, on its own, go down and tunnel below the surface. And so this mission ended in December 2022 because for its power, it was using solar panels. And the solar panels, unfortunately, on Mars, can be a big issue because there's a lot of dust that gets circulated around from the winds and stuff. Even though it's a very low atmospheric pressure, there's still dust. So we think of Mars like a desert, right? So there's lots of grains of sand and dust particles that can get kicked up. In fact, Mars is well known for having dust storms at times.
Now, the dust on Mars that we're talking about, for how it works, is much like flour. So that's why it can coat and stick to these solar panels and make it very difficult to get any light through them.
Yeah, and the thing is, even if Mars, I should say, had the right atmospheric pressure so that you could walk around on the surface without a spacesuit on, you wouldn't want to do it. You imagine breathing in that dust and getting into your deep in your lungs.
It'd be horrible.
Yeah, it would cause major breathing issues, and so you wouldn't want to do that. You'd have to be masked.
You would have to be.
You have no other way around that. But anyway, so when the lander solar panels got covered too much of this dust, and as it gets covered, the power that it generates from the solar panels declines. So it declined to the point where the power was just so low that essentially it died, right?
Okay.
And there have been other missions, and this includes rovers that we've had, Sojourner, it comes to mind, and other landers themselves that have solar panels, and they get covered with dust as well. But a lot of times you have these dust devils on the surface of Mars. Mars is strange, well, strange in a lot of ways. It's not like the Earth, but it has a lot of these dust devils. So you can imagine standing on the surface of Mars, looking out in the distance, and you see several dust devils ahead of you. At any given moment, it'd be kind of strange.
And all they are is updraft thermals.
Yeah. And so a lot of times they go by these spacecraft, like they go on top and they clean off the dust from the solar panels.
Right.
So it's like a free vacuum or something, right? And that then the power supply, is regenerated, right? The power that you get from the solar panels goes, essentially back up to where it should be. and you extend the life of these missions, of these vehicles.
InSight, unfortunately,
InSight landed in an area. Yeah,
any
InSight.
of these dust devils.
Yeah, InSight unfortunately landed in an area of Mars where the chance or the probability of a dust devil is very low. And NASA was waiting and waiting as the power levels went down, hoping and hoping that a dust devil would sweep by the lander and brush off some of that dust, but it never happened. And finally, in December of 2022, they lost communication with the lander itself. And the other thing is NASA keeps listening every once in a while, hoping that a dust devil will go by and sweep out the dust, and then the computer will be able to run the radio transmitter, start sending data back that we can pick up here on Earth. And from my readings, it's going to end this year. Once this year is over, they're not going to bother looking at it anymore.
Well, sooner or later, you're out of position. And
well, I think it's so cold, you probably electronics, crack because of freeze and stuff like that. So it's hard on the gear, right? When you don't have the warmth that you need, you can't run any heaters or anything like that.
Right.
Now, this lander was important. It was the first good seismometer that went to Mars and actually detected Mars quakes.
Which are a good thing.
And what can you learn from quakes, like earthquakes? In this case, it's Mars quake.
You can learn the densities of the interior. You can learn about if there's a liquid inner core or the solid core or how large the core is. You can learn all this type of stuff and how deep the regolith, the dust levels are. It's just, we want more seismometers. I'm going to sit there and say that. We want more. We want them with more stable power supplies so that they can run for longer.
Yeah, you make it nuclear. Perseverance rover is nuclear.
Okay.
So it doesn't have to worry about getting its solar panels covered with dust and losing energy.
So it can also use the heat just to heat.
Yeah.
So it doesn't need a heater.
Yeah, radioisotope thermoelectric generators, just like what runs the Voyager missions and the Pioneers and so on and so forth.
I didn't realize that.
Yeah.
That's sweet.
So that's what you need. and like you said, more of these seismographs on the surface of Mars, the better things would be.
Right.
In fact, you can fake, what do? They light off explosions here on Earth, right, to generate a fake earthquake.
Right. And you could do that to Mars. We could send a satellite into orbit that just had these rods that periodically would just shoot one down to create a big explosion and hence an earthquake.
Or if you're using some part of a spacecraft that detaches in Martian orbit as ready to send a spacecraft back to Earth, you could have that other stage that you no longer use crash into the surface of Mars.
Right.
And we did that on the moon. We crashed the bottom part of the lunar module. Crashed on the surface of the moon, and we would detect the vibrations.
The vibrations. We want seismometers. We want geophones on these places. So
InSight itself is near the upper center of this image. This is a recent image taken with the Mars Reconnaissance Orbiter. And so it's a spacecraft that is in orbit around Mars, and with the good camera that it has, it's able to zoom in on the InSight spacecraft so you can see it's there. And you also notice the color of it is consistent with the rest of the Martian surface itself. So it's clearly covered by dust.
It's clearly covered in a lot of dust.
And what they're using it for is to study how much of this dust accumulates on things like the InSight spacecraft, the lander itself. So it's still, they're going to photograph it occasionally, looking at, see how the color changes and how that relates to the amount of dust that accumulates on its surface. And you'd be able to tell if it turns all of a sudden it's nice and shiny and new, that means a dust devil went by, you see, and cleared off all that
all
dust.
the dust.
So you'd be able to estimate how long that took, how many years, given the location where the lander's at on Mars itself.
Oh, wow. I just looked up MRO because I was curious about when it got to Mars. It got to Mars on March 10th, 2006. Yeah. So it's been there for a while doing phenomenal work.
Yeah, in fact, we're always advancing our technology. At some point, we need to put up another orbit around Mars, even higher resolution cameras.
Right.
To see even better. So that would be interesting.
Would be interesting.
Now, we talked a lot about the Parker Solar Probe. So this is related to that. So in this case, instead of talking about solar flares, we're talking about superflares.
Okay.
Now, what this is about is a paper that was recently published related to a study taken by the Kepler Space Telescope. You remember what Kepler was used for? Mainly
For mainly looking for exoplanets.
Exoplanets. And the data, then you take so we look at a huge number of stars looking to see how they change in brightness. And that would be related to a moon, or I should say a planet that's orbiting that star, blocking out the light of the star periodically, and they're looking for signs of that. So it's just one technique we can use to find planets going around other stars. And so with this data of all these brightness measurements of literally hundreds of thousands of stars, you can do a lot of science with that. And this paper, what they looked at was sun-like stars, so stars that are like our suns, and you get that by looking at their spectroscopy. So they have spectral features that are consistent with what our sun is. So our sun is a G25 star, so it's a main sequence star, G2. That's a spectroscopic type. So you look for other G-type stars that are like our sun. And they looked at a sample of 56,000 of these stars. So that's a pretty big sample.
That's a good sample. Yeah.
And what they found for about 3,000 of these stars, which is about 5%, that they occasionally would have a superflare event. So a superflare would be a solar flare, except that it's much more powerful. If you think of a standard or average sort of solar flare, right? Or if you like, what is the most powerful of all of the flares that you would see coming from the sun? These superflares are about 100 to 1,000 times more powerful in terms of energy release.
Right. And we had a solar flare, not one of these super flares, a solar flare energized the atmosphere badly enough not too long ago that the northern lights were seen down in Georgia and
back in May of this year.
Right.
Yeah, May of this year.
So think about that. That much power is just a normal flare. These are 100 to 1,000 times more powerful than that.
Now, and so the statistics, which you can say something about now that you're looking at such a large number of these stars, the statistics tell us that a sun-like star will undergo one of these super flares, very powerful solar flare, once every 100 years or so on average.
We're overdue. Because we pretty much have a pretty good idea when the last one happened. Because it was called the Carrington event, because don't remember his first name, but Carrington was observing the sun, saw the flare, and this thing set telephone wires on fire.
Telegraph.
Sorry,
There were no
not telephone.
That was before Alexander Graham Bell, right?
Yeah, telegraph wires on fire.
Yeah, the poles themselves, and people. And you can go back and look at the archives of the newspapers back in those days, and they report, the presence of the northern lights from the United States, in this case, all the way down south.
And Havana, Cuba.
And they lasted for several nights in a row.
Right.
So it was a major type of eruption on the surface of the sun. These super flares, right, are probably more powerful. In fact, they mentioned are more powerful than even that event in the 1800s.
Wow. So, yeah, the Carrington event would have blown our current power grid.
Oh, yes. And then we got all those satellites in Earth orbit.
So one of these flares would do that on spades, apparently.
Now, that's why it's important to keep an eye on what the sun does. You can't just, if you have the opinion that whatever happens beyond the Earth, whatever happens in space, whether it's in our solar system or outside of our solar system, has absolutely no effect on us at all and will never have an effect on us. So why spend money? Why study it? That's absolutely wrong. What happened to the dinosaurs?
Right. Yeah,
right? They get hit by an asteroid, hits the Earth. Well, obviously that came in from outside of the Earth. So if the dinosaurs would have had the technology to pay attention to asteroids in our solar system and was able to do something about it, they'd be still around today, as the joke goes.
Yep.
Well, the other thing is monitoring what happens with our sun. So we have spacecraft that are closer to the sun than Earth's orbit. And so they would be able, now these charged particles that do major damage, they travel at less than the speed of light. So you could send a signal from these probes that are closer to the sun to radio back to Earth to say, hey, we just detected this big event happening on the surface of the sun.
Shut everything down.
Yeah, and then so satellite companies, for example, can shut down their satellites in Earth orbit. Now, a lot of people would be mad, right? If you have, you can the Mike Tyson, Jake Paul flight on Netflix wouldn't happen. Maybe that's what happened this time. I don't know. But things like that, right? It would have a dramatic impact on what we do in terms of entertainment, communication, our daily life, bank transfers, wiring money, all that kind of stuff is related to all this technology.
How we would save the power grid from being blown by such an event would be to actually shut it down. Yeah. So for several days, we'd have no power.
Yeah, GPS system, the whole thing, shut it all down.
Yep.
And once the event is over, then reboot everything back up again.
Right. So.
And keep your fingers crossed that you didn't have no major damage.
It reboots.
And almost like the Y2, remember the Y2000?
Yeah.
Yeah, the
I remember that.
Yeah.
It turned out to be a dud.
Yeah, everybody was really afraid that nothing would work, once the clock struck midnight.
Now, that said, there were pieces of software that stopped working because they were made to recognize that the date was wrong. And so shut down and said, hey, you've clearly pirated this because the date's wrong.
Well, I mean, things were repaired beforehand, right? We didn't wait for 2000.
Oh, they did for the major systems, yeah.
Yeah.
I happen to know that I had a few games that I had to go in and actually hardwire back the date.
I see. Yeah. So I remember there was a big call for people to come out of retirement who knew Cobalt and Pascal and all these obscure programming languages, but they were still being used in major infrastructural systems and had to go in and change the programming. So then when the year went from 99 to 00, it wasn't 1900, it was 2000.
2000.
And that caused a lot of the Y2K scare, or whatever we called it, right?
Yep.
So we were proactive on that. So same kind of thing. We're being proactive here to make sure that we don't have major disruption in society. Well, part of this is understanding space weather.
Absolutely.
And NASA and other organizations in the United States, you can think of the military or even like the weather service people.
Plus all the other nations of the world have their own versions
have put up satellites to monitor the space weather, what's going on with the sun and the environment around the sun, including what's going on with the Earth itself. So it's extremely important. And because it costs a lot of money.
Right.
If everything, imagine if all the satellites were completely destroyed in Earth's orbit, how our society, at least here in this country, would change.
I wouldn't like it. I mean,
would we be back like the Amish back in those days?
We would for a while at least.
We'd have to.
We'd have to. Because everything is designed and works on electricity and all of a sudden that's all gone.
Well, just think of the reliance on GPS systems nowadays.
Right.
When that goes away, everybody starts running into each other because they don't know where they're going on the roads. They forgot to read the maps and directions and all that kind of stuff.
Map? What's a map?
Anyways, we'll see what happens here. Now, another interesting paper that came out recently is about the rings of Saturn.
Mm-hmm.
Now,
I like the rings.
I remember that there was a lot of discussion early on. This was in the time when we were thinking about sending spacecraft by Saturn. That would include the Pioneer 11 in 1979. Voyager 1 and 2 followed up in the early 80s, and then eventually the Cassini mission came that went in orbit around Saturn. How old are the rings? How long have they been around for? And I remember first hearing about there's some they must be as old as the planet themselves, right? They literally should be billions of years old. But that's not what the data showed us.
That's not what the data is showing, yeah.
The data showed us that they are on orders of hundreds of millions of years old.
Right.
And I thought that's really weird because so why didn't the planet have rings for the first almost 90-some% of its life, and then the rings appeared, or is it episodic?
Yeah. I will sit here and point out that people should have known this because they're inside, I forget the name of the limit.
The Roche limit.
The Roche limit. So some of them are inside the Roche limit. So those are going to fall into Saturn. So the rings should have disappeared. The ones that are outside should have been flung off. So they should be gone. So the ring should be a temporary phenomenon.
And well, this new study says that's not the case. These rings are actually billions of years old now.
Interesting. I will have to look this paper up and see why they're saying that.
Now, the evidence to show that these are young, right, is because when you look at the rings themselves, and we have really close-up images from the Cassini mission, they don't show the dirty deposits that micrometeoroid impacts would have on the rings themselves.
Oh, good
So
point.
if you have a ring system that's freshly made, it's nice and shiny, and you expose it to the harsh space environment, over time, because of bombardment of various particles of different types, it will make them look darker in color.
Right, or just the photoionization of
They get,
various chemicals that are not water.
well, for lack of better word, they get weathered.
They get weathered. Yeah.
And the rings don't show weathering, so there must be young. Well, this work shows that by simulations that what happens is that these micrometeorites, the dust that would come from their impact on the rings, actually is charged.
Okay.
And these charged particles are either thrown out of the system or crash into Saturn itself. And they don't cause the dark weathering features on the rings themselves.
Interesting.
So that they speculate these rings could possibly be billions of years old. And that would get around the fact is, okay, if they're on orbits that are stable enough.
Right. And that's what I would then want
Yeah.
to see is the calculations of how you get an orbit of this type that would be stable
In
enough.
fact, and they have to be stable for a long period of time. And the reason for that is there's a ring around Jupiter, there's a ring around Uranus, there are rings around Neptune.
Right.
You wouldn't have all, if the rings were the short-lived phenomena, why do you have rings on all the major planets?
Okay. And my counter to that is why, if they're long-lived, then why is Saturn the only one with a prominent ring system? You would think the others would have nice prominent ring systems too.
Yeah, they would change. In fact, there's even some asteroids that have rings, like the Kuiper
Right.
Belt objects.
Yeah.
So rings are not one of these phenomena that we thought was extremely rare. There's more to it than that.
There's more to it.
Yeah.
And
So this study is interesting from that point of view, that maybe it's questioning the idea that these rings are very young.
yeah. And I'm all for that. Let's
Yeah.
let's question, let's get some evidence, let's get some data.
For sure. Now, the next thing I wanted to bring up is the fact that NASA, and obviously we have the Hubble Space Telescope that was launched in 1990, and we have the James Webb Space Telescope, which was launched a couple of years ago on Christmas Day.
Okay.
We have another telescope that NASA, another large space telescope that's Hubble-like in some sense. It has a mirror that's similar to Hubble's, 2.4 meters in diameter, and it's ready to be launched, it looks like, by May of 2027. And it's in the news today. There's a picture of it there where the scientists are actually taking the instruments and matching it or hooking it up, connecting it with the main part of the telescope itself, the main body of the telescope. This is known as the Nancy Grace Roman Space Telescope, named after an astronomer who worked at NASA for many, many, many years. She's passed away just, I think, a couple of years back. And so in her honor, the Roman Space Telescope. Now, this has an interesting history. Back a few years ago, the National Reconnaissance Office of the United States, the spy agency, contacted NASA, number one, which is unusual, probably. Well, that at least publicly we know about it. Contacted NASA, said, how would you like to have two space telescopes that are similar to the Hubble for free? We don't need them anymore. Now, that's the interesting part. You don't need them anymore. Obviously, they were designed to look down at the Earth, not to look out in space. But they don't need them anymore, which means they're doing something. What do they got now that we don't have?
Now, right?
See? Now, it's all right to say, NASA, here are two telescopes. Do what you want with them. These telescopes, by the way, are on the ground, so they never launched them.
Okay.
And NASA was like, oh, well, we could certainly use them. We could launch them as, Hubble Space Telescope 2 and Hubble Space Telescope number 3. And it turned out, of course, you need money. You had to retrofit these things, right? You had to. It's like someone giving you a Lamborghini. So here, Robert, I won the Powerball last night. I'm going to buy you a Lamborghini. And you're like, oh, great, thank you, Wayne. I want that Lamborghini. And the next thing you say is, oh, could you also give me the money to cover the insurance that I need per year?
Right.
That's the problem.
That's
right?
the problem.
So NASA had to get money from Congress. They don't have their independent way of making money to actually, take these two gifts and make something out of it. And what they decided was to combine them into one telescope now instead of two. And that's what has been approved. So the Roman Space Telescope then will contain two primary instruments. One is an optical wide field camera and will work also in the near infrared. Now, the mirror is different from the Hubble. It's comparable in size, but different in the fact that it's designed at different F ratios, we would say, so it looks over a much wider area.
Right.
And in fact, it will look over an area in one image that's 100 times the area that Hubble can do.
That'll be impressive. Talk about your ultra deep field.
So you're looking at about 0.28 square degrees in size for each image.
Right.
And if you want to do a large survey of the sky, this is the instrument to use, not the Hubble. The Hubble's great for like pinpoint target. You go to one specific object, take an image. It's really, really, really hard to do a large, wide area survey because you got to look at so many
little pieces
and put them together. So this spacecraft, this telescope was designed to look at a much larger, field of view than the Hubble Space Telescope.
Cool.
The other instrument is a chronograph.
Oh.
And that piques your interest because you can definitely look. It's a little occulting disc, essentially, that blocks the light from the bright area of a star, allowing you to see anything that's very faint near the star itself, like, for example, planets going around a star.
Yeah.
So this telescope, which is operating in space, so it's operating at a very high resolution, the diffraction limit of the telescope, essentially, and it's not worried about the blurring effect caused by the Earth's atmosphere. Right. And by the way, for those who are interested, if you're wondering about the blurring effect caused by the Earth's atmosphere, go to YouTube sometime and look up Mauna Kea, the Subaru telescope, and there is a live webcam that runs at night, and you can actually see the big Keck telescopes in front of the camera, and occasionally, which means every night essentially, you'll see lasers going up from the telescope into the sky.
Ooh, and so you can see the ones, the artificial stars.
Yeah, and that laser is part of the adaptive optics system that we use to kind of try to compensate for the blurring effect of the Earth's atmosphere. It's not perfect, so if you want perfect, you get above the Earth's atmosphere.
Right.
And the other thing is, once you're up there, a lot of the other light, doesn't that you want to look at, you can easily detect it. It's not absorbed by the Earth's atmosphere.
Right.
And that includes out in the infrared where water and carbon dioxide have a major problem.
Because except for a very narrow band width, the Earth's atmosphere is black, folks. It absorbs everything.
And this telescope is due to be launched in May of 2027. It's not that far away. Like a little over 2 years.
Yeah.
So and hopefully the Hubble's still working.
Oh, right.
And yet, here's another thing. So did you hear who Trump has picked as NASA administrator?
No.
That Jarrett Isaacman, the guy who flew on the Polaris Dawn mission.
Oh,
remember he did his own private. He's like a billionaire or something, and he flies jet aircraft. He was the one that wanted to put his own mission together. I think he was going to pay for it to go up and repair Hubble.
Okay.
And he could potentially now, it looks like he's going to be NASA administrator.
Interesting. So we'll see where that goes.
That's what I'm thinking. I wonder if they'll actually have a mission to refurbish Hubble.
Yeah.
So you can have the Hubble up there as well as these other things.
Take a lot of work to refurbish Hubble.
Well, you have to replace it. You have to do another. I mean, it's designed to be instruments to be replaced. We've had several missions where astronauts went up and swapped out instruments. And what's really affecting Hubble now is this gyroscopes.
The gyroscopes.
So if they can at least have a mission that replaces the gyroscopes, that will give it a new leash on life.
Okay.
And that's something that's doable.
All right.
So we'll see where that all plays out. The other thing, too, that was in the news lately, I wanted to make a mention of, is monitoring of a galaxy known as M87.
M87.
And this galaxy is very special. It's what we call an active galactic nuclei, or an active galaxies. Mm-hmm. And what makes it that designation is that it has a supermassive black hole at its heart, and most normal galaxies do, so that's not unusual. But it also has a large accretion disk, material that surrounds the black hole, that's outside of the event horizon, moving in orbit around it. And that material gets heated up and emits radiation. And one of the things that comes from M87, if you look at it, even with just an amateur telescope, you can see a jet of material coming off the galaxy. So back several years ago, the Event Horizon Telescope, which is a collaboration of many astronomers, mainly using radio telescopes to look at different black holes. They're trying to resolve them. In fact, they did resolve the black hole at the center of M87 and also the one in the center of our own galaxy, the Milky Way. Mm-hmm. And so there's also sort of a follow-up collaboration that works with this, looking at different galaxies over multiple wavelengths. And that would include, for example, the radio wavelengths, as well as X-rays, gamma rays, optical, ultraviolet, infrared, you name it. And one of the things it discovered then is that there is a flare right? And that's the image you can kind of see taken in different wavelengths on the right-hand side, that there was a flare in gamma rays that was emitted by M87 during the time that they were watching it.
Okay.
And that was really unusual to see such a energetic flare coming from an active galactic nuclei like
Right.
that. Is very rare.
I
One
mean,
every 10 or 20 years or so on average.
I mean, in astronomy, you're lucky if you see something change in your lifetime that's outside the solar system. To see something change rapidly by human timescales is wow.
Well, the thing to note here is this. You don't realize the things that you can see if you look at an object over multiple wavelengths simultaneously for a long enough period of time,
Something's going to
that
change.
any type of rare event that would be missed normally by people on Earth is actually observed. And that's what this really reflects.
Yes.
That there is a lot of science that you can get by watching objects, whether they're galaxies or stars, you name it, over a large area of the electromagnetic spectrum, and you look at it simultaneously for a long enough period of time. Any time this object hiccups, we can find it. We can pick that out. And we're always looking for the rare things, because that's what makes science really interesting, is try to explain why they're rare.
Why they're rare and what happened. So,
Anyways, if you're into this kind of stuff, if you like science, there's lots of things you can do is to educate yourself, number one.
that's
And
the
you
first thing.
go to higher education institutions like the University of North Dakota here in Grand Forks. We do have programs that are both online and on campus. And if you happen to be on campus at any time, please look us up.
Let us know. Come by and see us.
Exactly. Now, the next podcast, as I mentioned, will be in the new year on January the 7th. We always leave you a quote.
Mm-hmm.
This one, and we talked about Mars today. Robert actually guessed it accidentally.
Oh, I guessed who
that
the
quote
person.
comes from. Percival Lowell. Do you want to say a few seconds of who Percival Lowell was?
Percival Lowell, I don't know a detailed history of him, but I do know that he was the one who, with Clive Tombaugh, discovered Pluto. So he is a planetary astronomer. I know that much. He was politically big within the astronomical community, so that he was able to push his opinions through a lot of times.
And what was one of the things he said about Mars that he's well known for?
That I don't know.
Oh, he was the one that proposed the idea that Mars had canals all over its surface, which was a sign that it was populated by Martians.
Yep.
That's what he proposed.
Okay. So he bought into Schiaparelli.
Yeah, well, he took the idea of Schiaparelli and changed the Italian word for canali to canals as a man-made objects type of thing, and speculated there was life on Mars that had an irrigation type system, and that it would change over the seasons because as the
crops grew.
and the water moved around, the rainy areas and so on and so forth.
Yep.
So here is a quote from him.
All right.
Speculation has been singularly fruitful as to what these markings on our next to nearest neighbor in space may mean. Each astronomer holds a different pet theory on the subject and pooh-poohs those of all the others. Nevertheless, the most self-evident explanation from the markings themselves is probably the true one, namely, that in them we are looking upon the result of the work of some sort of intelligent beings. The amazing blue network on Mars hints that one planet besides our own is actually inhabited now.
Wow.
Which told it to be totally wrong.
Wrong.
But it got Mars, the interest of Mars. And in fact, that leads eventually to the fact that, like War of the Worlds, where we get this creatures from Mars, i.e. Martians, right?
Right.
And it haunts our nighttime dreams, this kind of stuff.
And we're still worrying about it.
Anyways, everybody have a happy holidays. If you celebrate Christmas, Merry Christmas. If you don't, Happy New Year, all of that.
Yep.
And we'll see you in January.
See you in January, folks.